do these questions, you have to know what the perfect cubes are. So you guys probably know perfect squares, you know, like 1, 4, 9, 16, 25. So let me just see if I can squeeze. I'm going to write them on this side. Okay, so perfect cubes. So like to the third power. If I do 1 to the third power, that's 1. If you do 2 to the third power, that's 8. You're going to see these numbers in the questions today. That's why I'm jotting this down. All right, 3 to the third power is 27. And I think I need to go up to 10, so I'm going to keep going here. If you do this on your calculator, you get these same things. 4 to the third is 64. 5 to the third power, 125. It just means like if I do 5 times 5 times 5 again, that's what I would get. All right, 6 to the third, 216. Like I said, you're going to see these numbers on the paper today, and I need to put these up on the board. 7 to the third power, 343. 8 to the third power is 512. 9 to the third power is 729. And I don't think anything goes any higher than this. 10 to the third power is 1,000. We could obviously keep general, like I could do 11 to the third power or 12 to the third power, but I don't think any of the problems go over 10. So here's the way this works. I'm going to give you the little formula here. If we have a cubed minus b cubed, difference of cubes literally just means you're going to see subtraction. What we're going to do is we're going to factor that into this little formula. So this is equal to a minus b, and then the rest of it's a little set of parentheses that'll be a quadratic. It's a squared plus ab plus b squared. Now, the key to these questions is identifying a and b, which they could be variables or they could be numbers. The b is usually a number and the a is usually a variable or maybe a variable and a number. So we're going to go through how to do that here real quick. And then you literally just plug it into this formula. Okay, now what I have is my first thing just says factor each of the following. So we're just going to use that formula to help us do that. So if I have x cubed, I know this is kind of weird, but what I'm going to do, I'm going to write it like this. This is x cubed. Now, if you guys look at that list that we just jotted down, 8 to the third, or sorry, forgive, I'm looking for 8 on this list, so it's up here at the top. 8 is the same thing as 2 to the third power. So I'm just really, in this question, doing x to the third minus 2 to the third. So I'm just rewriting that to help you guys plug these into the lovely formula we're going to use. All right, in this instance, our a, everywhere we see an a in that factoring formula, we're going to replace it with x because that's the first piece. And everywhere we see a b, we're just going to replace it with a 2. So I'm just following the formula directly above this lovely picture here. All right, so it's a minus b. So I'm going to write x minus 2. Now, this part is a little bit trickier. So a squared would be a squared, so a is x, so we're just going to do x squared. A times b, this would be x times 2, but typically you put the number in front, so I'd probably write that as 2x if I was writing that problem out. And then the last step is b squared. So b is 2, so I'm just squaring 2, which is where I'm going to get 4. And if you're like, what the heck? So a times b, this is a squared would be x squared here. A times b would be x times 2. I'm just writing it as 2x because that's the typical notation to put the number in front. And then the 4 is b squared, which is 2 squared. So that's where those are coming from. I just kind of simplified it as I put it into the problem. Is anybody having a question at the moment? All right, let me try this one. Okay, so if you see a number, come over here to this list and look, and you see 125. So 125 is really 5 to the third. So I'm going to write 5 there, and thank you, ma'am. I'm going to write x to the third. Because 125 is 5 to the third, and x to the third is x to the third. Now, do you guys see the 64 on the list? What number am I going to write for the 64? 4, right? Okay, so 64, I'm just rewriting this. 64 is 4 to the third power. I'm trying to figure out what I'm taking to the third power to get my a and b values for that little formula. All right, now, this one I think is the hardest if you have a number in front of the x for the second part of that little formula, but the first part's not too bad. Your b here would be 4. So I'm just following along here. So a, this would just literally be 5x, a is 5x, and minus b, which is 4. Just copy that right on in there. Now, the tricky part on this one for sure, I think, is, I'm going to write this above here. So the first term here is a squared. So a is 5x, and I need to square that. The thing everybody messes up here is they forget to square the number. So you have to square the 5 and you have to square the x. So 5 squared is going to give you 25, and then x squared will give you x squared. It should be, if you guys want to check these, if I take the first term here, like the 5x, and multiply it by the first term here, which is the 25x squared, 5 times 25 will give you back the 125 from the original problem. X times x squared will give you the x cubed from the original problem. Okay, now in between here, this is a plus sign, and you're going to do a, which is 5x, times b, which is 4. So just literally doing 5x times 4, that'd be 20x. And then the last term is plus b squared. B for this problem is 4, so we're going to square 4, so that's going to be 16 in the formula. And if you guys were to sit there and FOIL this back out, it will give you the original problem that we had in just the beginning of the question. It's just we want to put it in factored form because eventually we're going to solve these on the back, and it's easier to do from factored form. Okay, I got one more. See if you guys can try this one. So that first term's just x to the third, right? So I'm just kind of writing it like that with the little parentheses to help identify my a value. And if you look at your list over here, you're going to see 27 goes with 3 to the third power. All right, so I got a is going to be x here, b is going to be 3. So see if you can follow that formula and set up like what the factored form would look like. So a is going to be replaced with x, b is going to be replaced with 3. You guys are doing that real quick. I'm just going to write these up. And I'm not going to use any numbers that are not on this list. Okay. What'd you write for your first little set of parentheses? What minus what? Perfect. All right. Anybody want to try the quadratic? What'd you write down? Go ahead, Zion. What do you think? Okay, perfect. Exactly right. Exactly right. If you guys do want to try and multiply this out, you totally can if you want to. We have done this in some previous lessons. I just didn't call it this. But if you multiply that out, all the middle terms will cancel out, and you'll just be left with x cubed minus 27. Okay, now, let me scooch this up a little bit. This formula is almost identical to what we wrote down, but it's just going to switch a plus and a minus sign. So the sum of cubes, you're going to have two things added together that both can be cubed. Okay, now if it's a plus, your little set of parentheses starts with a plus b. If it's a minus, it starts with a minus b. And I'm literally just going to switch a plus sign and a minus sign to do this. All right, this is still going to be a squared. The only difference here, this is going to be minus ab and then plus b squared. It's very, very, very similar. It's just the first two signs are switched. In the difference, it's minus plus plus. In this one, it's plus minus plus. And then very similar question. So I'm going to write down, like this guy right here, we're just going to plug these in. This is x cubed. 8 is 2 to the third power. So when I replace these guys in the little formula, a is going to be replaced with x, and b is going to be replaced with 2. This is going to be almost identical to that very first question I did. The only difference is going to be where a plus sign and a minus sign is. So this is a plus b, so it'd be x plus 2. Now a squared would turn this into x squared. A times b, again, this is, so this guy's x squared. A times b would be x times 2, but typically you would put, like I said before, the 2 in front of that. So this would be minus 2x, and then on the end, it's b squared, so it's going to be 2 squared. It always ends with a positive when you're working with these. The last sign is always positive. And again, if you multiplied that back out, it would give you x cubed plus 8. All right. Now, I know you can't really, oh, can you guys see the list on the board? Can you tell me what number goes with 216? Or look on your paper. What number goes with 216? 6. So this guy is 6x to the third. What number goes with 729? 9. All right, so 729 is 9 to the third. All right, so in this case, my a is going to be replaced with 6x. This one can be tricky, and my b is going to be replaced with 9. But let me pull that back down so you guys can see the formula. Sorry, I had that off the screen. All right, now, all I got to do, just a plus b, so 6x plus 9. This is the part that I think is the very trickiest one, is this first term in the quadratic. So a is 6x, and we're going to square 6x. The thing people will forget, they forget to square the 6. So you got to do 6 squared, which is going to give you 36. And then x squared would be x squared. And if you want to check this first term, if I do 6x times 36x squared, that should give me the first term right here, which is 216x to the third. All right, in between, we're subtracting here, and then we're just going to do a times b. So a times b here would be 6x times 9. So 6 times 9 is going to give you 54. Just put an x with it. And then your last term is b squared. So my b value is 9. So that's going to be 9 squared. This will be plus 81. If you want to check the last number, if you do 9 times 81, that should give you the number on the end here, which is the 729. And then I got one more, and then we're going to solve some of these on the back with this practice. Now, this one always trips people up, but 1 is always a perfect whatever you're working with. So this is x cubed. 1 I could also write as 1 to the third. 1 to any power is 1. Like I could do 1 to the 30th power. It would still be 1. Just 1 times 1 times 1. So 1 is sometimes something people forget about, but that is a perfect cube. So we can put this in here. And here, your a would be x, and your b would be 1. So you guys, or here, let me pull that back down so you can see the formula. All right, see if you can set this one up. So your a is x, your b is 1. What would it look like if I put it in that factored form? So you're going to have a little set of parentheses with just 2 terms, and then you're going to have a quadratic. What would you write for your little, like, what would the little first set of parentheses be?
X plus 1.
X plus 1. Okay. Then what would you write for your quadratic? Perfect. X squared. This one's kind of weird because you're just multiplying by 1, but it's just minus 1x or just minus x. and then plus 1. If you did multiply that back out, I promise it would give you x cubed plus 1. Is anybody having a question about how to factor this? Okay, the purpose of doing this is what I'm going to show you on the back. And I know this is going to look kind of complicated here, but what I have at the top, you have to use this on all the questions. I literally just put the quadratic formula up there at the top. That's what's going on. And then these are the two formulas we had for factoring here. All right, this one is the sum of cubes, and then this one is the difference. So these are the ones I just gave you on the front side of the notes to help you factor these, because that's what we're going to work on here. Now, I think, yeah, these guys on the back are all different than the ones on the front. Okay, now, here's the deal with these. So it says you'll always need the quadratic formula when solving the sum and difference of cubes, because 2 of the answers are actually imaginary on all these questions. And then, I'll show you this as we do the problem, but the second part says whatever's under the square root in the quadratic formula is always going to be divisible by 3 and a perfect square. So quadratic formula is at the top, just to help you guys remember that, because we're going to need that on these questions. And then we'll get into how to break it down here in a second. So do you guys remember how to look at an equation and just tell me how many answers there are? So like I have x cubed plus 343. Do we know how many answers that has just by looking at the equation? It's 3. Yes. Okay. So this it matches the highest exponent. So this has 3 answers. Now, typically what people do, they're like, oh, Miss Gertie, it's so easy. I'm just going to subtract 343, and then I'm going to take the cube root. Well, that only gets you one of the 3 answers. So that's why I showed you guys those formulas on the front. One of the answers will be a real number. The other 2 are imaginary. So that's why we've got to use the lovely quadratic formula on this. Okay, this guy's a sum of cubes. So I'm just going to factor this real quick. In this case, we would have x cubed plus, if you look at that list, 343 is 7 to the 3rd power. So I'm just using our little factored form. It'd be a plus b, so I'm going to do x plus 7. And then I'm going to do a squared, which would be x squared, minus, for this one, a times b would be x times 7, or 7x. And then b squared is 7 squared, which is 49. So I'm just using the exact same thing we did on the front. We're just going to solve this equation. Okay. The first part, once you set this up, is super easy because I've got 2 things multiplied together to give me 0. So if the first thing is 0, that would just be right here, just x plus 7. You guys could probably do that in your sleep. That's negative 7. Negative 7 is going to be one of my answers. The other 2 answers, if you've set this up correctly, the other 2 answers are always imaginary. So what I'm going to do to find the other 2 answers is I need to find what sets this equal to 0, and that's where you're going to use your quadratic formula. So I've got it at the top of the page if you want to look at it. So I'm just going to use, this will give me my other 2 answers. We're just going to use the quadratic formula. All right, in my quadratic formula, it's the opposite of b, so it's going to be positive 7 plus or minus square root. B squared is negative 7 squared minus 4 times 1 times 49. Everybody over 2a, be 2 times 1 here. Now, I promise, whatever is under the square root, it's not ever going to be a perfect square if you did this correctly, but you can always divide it by 3 and a perfect square. We're working with sum or difference of cubes, that's how I remember that. So if I just do like my negative 7 squared, I'm just doing under the square root. 4 times 1 times 49, you're going to get 7 plus or minus, this would be negative 147, and the negative is why I'm telling you guys it's going to be imaginary, because that's how these set up every single time. The other 2 answers are imaginary. Okay, I promise, whatever is under that square root is divisible by 3 and a perfect square. It says that up in the directions above. So I'm just going to tell you this. I'm just going to divide this by 3 real quick, and you'll see that that's 49. 49 is a perfect square. I know it's negative, but it's going to be a perfect square for our purposes here with imaginary stuff. So I'm going to write this as negative 49 times 3. What would you guys tell me the square root of negative 49 is? 49? 7, right? Okay, now, do you remember what to do if it's negative? Like 7 what? 7i. That's all you have to do. Now, these two numbers outside here, like if this is 7, this will also be 7 whenever you set these problems up. And then this is 3 all over 2. Those are my other two. That's 2 answers. This is 2 answers because of your plus and minus. You're just going to use the quadratic formula on that. So negative 147 is the same thing as negative 49 times 3. So I just divided. Whenever you do these problems, they always have a 3 under the square root when you simplify it. But just whatever you get under here, divide it by 3, and the other number will be a perfect square that you can take the square root of. You're just going to have to put an I with it. Let's just try one more real quick. I don't remember if we factored this guy on the front. Let's see. So this would be x cubed minus 4 cubed here. Let me flip back for 1 second. Did we do this one in the front? Nope, we didn't. Okay, so we got to do this real quick. Now, my factored form is going to be a minus b. So it'd be x minus 4. And then it's a squared, which would be x squared. A is x here, and b is 4. Now, this one's a plus. A times b would be 4 times x, so 4x. And then b squared is 4 squared, which is 16. Okay, should have 3 answers because it's x to the third. The first one's easy, so you just got x minus 4, so just 4. The second one's the tricky part. We got to do the quadratic formula on this guy right here. All right, so I'm going to do opposite of b, which would be negative 4, plus or minus square root. Be 4 squared minus 4 times a value is 1. C value is 16 for that quadratic, all over 2a. Negative 4 plus or minus. All right, I'm going to just grab my calculator real quick. I promise whatever this is, though, is divisible by 3 in a perfect square. It's 4 minus 4 times 1 times 16, which is negative 48, over 2. Now, I promise, whatever that number is under the square root, this is negative 48. It is divisible by 3 and a perfect square in imaginary land. So just take that number, divide by 3, think difference of cubes, sum of cubes, whatever. It will be divisible by 3. You will have a 3 under the square root if you did this correctly. So negative 48, this is the same thing as negative 16 times 3. And you'll notice when I do this, right? Square root of 16 is 4. Square root of negative 16 is just the only difference. It's 4i because it's negative. And those two numbers on the outside, like I know the first one is negative 4, but the two around the plus sign, they'll both be the same number. It just could be that the first one might be negative. So this one's a little bit tricky. This is negative 4 plus or minus 4i radical 3, the whole thing over 2. Can I simplify this?
Yes.
The last question, no. This one you can. Like 7 and 7, neither of those are divisible by 2. Okay, don't touch the radical. These always have a radical 3. So if all 3 of these guys, I got negative 4, I've got 4i, and I've got a 2. Those are all divisible by 2. Don't touch the radical, but you can actually divide those other 2 terms. So negative 4 divided by 2 is negative 2, plus or minus. 4i divided by 2 is 2. 2i, sorry, and then radical 3. Because they should always have an I, and they should always have a radical 3. So those are my 2 answers. So my one answer here, 4, and then because of the plus or minus, there's my other 2 answers. Then we have all 3 answers to that question. Is anybody having a question? Okay, we're just going to do one more real quick. And like I said, I know these are a lot. All of these, if you're solving the actual equation, you got to get 3 answers. You got to use the quadratic formula. All right, so this guy is the same as 512 is 8 to the third power. So this is 8x cubed plus 27 is 3 to the third power. So for this guy, my a is going to be 8x. And my b is going to be 3. So when you use that sum or difference of cubes, this is a sum of cubes here, you got to be careful because if there's a number in front of the a, like this is 8x, I always think that one's tricky. So your factored form, we're just going to have 8x plus 3. Now, this is supposed to give me 512x cubed if I put this next term. It is, let me grab a different color here. This is 8x to the third. Squared, fired. Okay, you square the 8 and the x both. So this is going to become 64x squared. Then it's minus. A times b here is going to be 8x times 3. So we're just doing 8 times 3, put an x with it. This is going to be 24x. And then it's always plus. B squared is going to be 3 squared if you're using that formula. So this is going to end up being 9. Easy way to check. If you multiply the first two terms together, 8x times 64x squared should give you 512x to the third. If you multiply the last two numbers, if I do 3 times 9, that should give me the number on the end, which is 27. Once you do that, we're just going to write our answers. Okay, this guy, we're going to set this equal to 0. If I set that equal to 0, I would subtract 3 and divide by 8. So I'm going to have a fraction there, negative 3/8. If you're like, what the heck, where did you come up with that? If you just take the parentheses, whatever sets that equal to 0 would set the whole thing equal to 0 if we put that in there. So that's what I'm doing. I'm subtracting 3 and then dividing by 8. So that's where that's coming from. You don't have to write all that out. Like I said, I just kind of think about it in my head, like, what would I do? I'd subtract 3, divide by 8. So negative 3/8. Now, the other one, unfortunately, we got to use the quadratic formula on. So I'm going to do opposite of b, so it'd be positive 24, plus or minus, square root. B squared is negative 24 squared, 4 times 64 times 9, everybody over 2a, which in the last two questions we did, the a value is just 1, so we just had a 2 on the bottom. This one, in front of your x squared, you got a 64, so we're going to have a different number on the bottom. Okay, now, we're going to do that negative 24 squared. I'm just doing under the square root. 4 times 64 times 9. And you're like, what the heck? This is negative 24 plus or minus negative 1728 under the square root. The bottom is going to be 2 times 64, which is 128. Now, I know that's a huge number. I would not tell you to sit down and break that down under a square root with a factor tree or anything like that. But I promise you, if you set this up correctly, that number is divisible by 3 and a perfect square. So I'm just going to divide that by 3 real quick. So I get negative 24 plus or minus square root 576. I'm going to put the negative with that. Okay, now 576. I'm going to do square root 576, just show this to you, is 24. It should match the number that's on the outside. That's just how these work every single time. And I'm running out of a little space because I was writing too big on that first question. But you'd have negative 24 plus or minus. We're going to have 24i radical 3. Everybody, excuse me, over 128. And I'm just going to reduce that fraction real quick because I have all those numbers divisible by, I think they're all divisible by 8. Alright, so 24, and you can grab your calculator to do this too. 24, 24, and 128, they're all divisible by 8. Don't touch the radical, don't touch the I. Actual answer here would be negative 3 plus or minus 3i radical 3, whole thing over 16. And I know there's one question like that on the homework that's a little bit tricky with bigger numbers. But whatever is under the square root is always, always, always divisible by 3 and a perfect square. Okay, so the 576, this square root of that would be the 24i. That's not going to be a number you guys are going to be probably super familiar. If it's a bigger number like that, just do a square root on your calculator. Just don't put the negative in front of it. And that's where I got the, did I do that? If I do like square root 576, that's where I got the 24. You just put the I with it because of the negative. That I promise. You always have a 3 under the radical when you do these problems. I just remember that because it's a sum and difference of cubes, so I think of the number 3. And then the other answer is that 3/8. Does anybody have a question? Okay. I would maybe either